values as example. Okay, so let me have here examples. So let me have x and y. Wait for a while. Okay, if my x is 0, then I will be having 1. If my x is 1, then I'll be having 2. If my x is 2, then I'll be having 9. And then if x is 3, I'll be having 22, and so on and so forth. Okay, so again, first step, inspect. So 3 minus 2 is 1, 2 minus 1 is 1, 1 minus 0 is 1. 22 minus 9 is 13. 9 minus 2 is 7. 2 minus 1 is 1. Oh, the first differences are different. So therefore, this is not a linear function. Let's see if this is a quadratic function. So 13 minus 7 is 6. 7 minus 1 is 6. There you go. Therefore, it is a quadratic function in which we are going to have this model. Y is equal to ax squared plus bx plus c. So, by using the shortcut, then it says here that your a is the second difference divided by 2. So therefore, for a, what is the second difference? So this is the second difference. So 6 divided by 2. Therefore, your a is equal to 3. Okay, so anyway, let us have a problem here. What if our x is 12? So what would be the y? So we already have the a, which is 3. Now for the c. For the c, it says here, c is the value of y if your x is 0. So from here, our x is 0, the value of y is 1. Therefore, c is 1. As simple as that. And then for the b, we have to solve. So b, question mark. Now I'll be using 1, 2. So using 1, 2. Okay. So y, this is my x, and this is my y. So that will give us 2 equals a, which is 3, x, which is 1 squared, plus b is still b, that's what we're looking for, times x, which is 1, plus c, which is 1. So this will give us 2 equals 1 squared is 1 times 3, that's 3, plus b times 1, that's b, plus 1. So what is 3 plus 1? 4. Transpose that. 3 plus 1 is 4 transpose, so that will give us 2 minus 4 equals b. Therefore, b is negative 2. There you go. You already have the a, the b, and the c. So, the model for this problem, the model now, or the pattern, or the equation, would be y is equal to a, which is 3, x squared, b, which is negative 2, so negative 2, x, your c, which is 1, so plus 1. There. Okay? Now, let us solve that problem. So, let me rewrite the model for this problem again, which is y is equal to 3x squared minus 2x plus 1. The point here is this. Again, I would like to reiterate that the purpose of finding the model or the pattern for a particular problem is for us to have an easy way of solving missing values if you're already given bigger values for either your x or y variable. So that's the point here. Okay, So if now your x is equal to 12, then this will give us y is equal to 3 times 12 squared minus 2 times 12 plus 1. So y would be 12 squared is 144. So 144 times 3, that will give us 432. Is it correct? 12 squared is 144 times 3. So you have 300, 120, that's 420. 420 plus 12, 432. Correct. Then minus 24 plus 1. So therefore our y would be, that's 432 plus 1, that's 433 minus 24. That will give us 409. 409. 433. So 409. Okay, so if x is 12, therefore the y is 409. And it's easier for us to solve for y is equal to 409 because we already have the model, which is y is equal to 3x minus 2 minus 2, 3x squared minus 2x plus 1. Okay, so that's the first follow-up problem for the shortcut. Let us have another one. Okay, let me use x again, then y. So for this case, let me have, if x is 0, y is 5. Okay, so I am actually going straight to the table of values, so I'm not having here mathematical problem. Anyway, this is a mathematical problem. What I mean is the worded problem. So just to give you a follow-up of that shortcut. So but for me again, I want you to review the substitution method and the elimination method, because that depends on the activity in which I am going to state the method that you're going to use. But by this time, so let me have the shortcut, no? So I hope you understand that, and I hope you're also getting it, okay, or everything about this. So if x is 0, y is 5. If your x is 1, then it will give us 7. If x is 2, then that will give us 9. If x is 3, then that will give us 11, and so on and so forth. How about if we have 21 here, then what? So again, you may continue this because the pattern is actually obvious. So to follow up only the shortcut for this one, so let us have the inspection. So excluding the 21, so 3 minus 2 is 1, 2 minus 1 is 1, 1 minus 0 is 1. Okay, there you go. All the differences of the independent variable are the same. So let's proceed here. 11 minus 9 is 2, 9 minus 7 is 2, 5 minus 7 is 2. Okay, first differences are the same, so therefore this is a linear function. Okay, and we know for a linear function, this is the pattern, the model, the equation, the function that we are going to follow. And going back to it, for the shortcut of a linear function, there. If it is a linear function, your a is the first difference, your b is your y, if your x is 0. Okay, so let me put that beside what we are solving. So therefore, our a is the first difference, which is 2. And the b is your y if x is 0. So if x is 0, y is 5. Therefore, that's also the value for the b. Therefore, the model for this is y equals a is 2. So 2x, the b is 5. See? Easy for the shortcut. Okay, but again, most shortcuts, no learnings at all. I'm saying most shortcuts, okay? But please don't be dependent on this. I still want you to be more into the long method instead of these shortcuts. because in the long method you are actually having a very comprehensive solution wherein you are applying many concepts that you have learned before, unlike for the shortcut you just substitute blah 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 and directly substitute, that's all. Okay, but shortcuts are actually very helpful in some other cases, like if you are having board exam. Shortcuts are one of the best methods to beat the time. Anyway, so our problem for this one is to solve for the value of y if your x is 20. So the problem here is we're looking for the value of y if your x is 21. Since we already found the model for that, or the pattern, then let me rewrite that. Y is equal to 2x plus 5. Now if your x is 21, so that will give us y is equal to 2, your x is 21 plus 5. So y would be 42 plus 5. And there you go. It's 47. Okay? And then if we're going to continue this manually, if it's 4, 13, I think, plus 2, right? 13, and so on and so forth. If you'll continue that manually, you will also get the same answer, which is 47. And the purpose again of having the model is for us to have an easy way of solving the problem. Okay. Okay, so let us now summarize our lesson for today. So for the linear function, we have similar first differences. For the quadratic function, we have similar second differences. And again, before you proceed to this, you must inspect first the first differences of the independent variables. Okay, now if the first differences for the independent variable for the linear function, the first differences of the independent variable for the quadratic function are similar, then you can now proceed to the this step for the dependent variables. Okay, now if the first differences are similar for the linear function, take note of this model, y is equal to x plus b, and then for the quadratic function, take note of this, y is equal to x squared plus bx plus c. Okay, and then for this linear function, since you have here two constants, so that means you will be needing 2 points. Okay, from my previously I have been talking about one set of points, two sets of points, no? So let me correct that. It should be only 1 point or 2 points, because when you say 1 point, that means it is already consisting of the x and the y. So for this one, that means 2 points. So you have point A, x sub A, y sub A, then point B is x sub B, y sub B. There. So let me correct that. No? Instead of saying 2 sets of points, so as long as you have understood it before, then there's no problem about that. Okay. So for quadratic function, since we will be needing 3 constants, so that means you will be needing 3 points. Okay. So where are we going to get the 2 points from the linear function? Where are we going to get the 3 points for the quadratic functions? So of course, we're going to get them from the table of values that you have constructed given the worded problem. That's why I am giving you a warning for that, because if you have misconstructed, or if you have the wrong construction of the table of values, then that means the solutions following to that table would also be wrong. Okay, so be careful. Okay, so once you're given the worded problem. So anyway, so for the linear function, you can do the long methods, which are the substitution or the elimination. And these are the same methods that you can also apply for the quadratic function. You could also do substitution and elimination. Okay, so these two methods are actually long. Okay, so I have already revealed to you the shortcut for linear function. A is the first difference, and then your b, which is this one, is the value of your y in the table of values if your x is equal to 0. And then for the quadratic function, the shortcut would be a is the second difference, divide by 2, then jumping to c, which is your y if x is 0. And then of course for the b, you have to solve. Again, to solve for the b, what are our conditions for that, or what are the things that we need to solve for the b in the quadratic function? So we need to get any point from the table of values. That means 1 point is enough, because in that point we have already the x and the y, and then use the values of a and c that you have first solved using this shortcut here. So with that, you can already solve for the b. Okay, now the dilemma for the shortcut is this: for the value of the b for the linear function and c for the quadratic function, because there are some table of values like this. Let's say x is 1, that's 5, 2, that's 3, 3, that's 1, and so on and so forth. So if you're going to look at this table of values, there's no 0 along x, so we cannot solve for the b if this is linear. We cannot solve for the c if this is quadratic. So if you really want to do the shortcut, then you could have 0 here, as long as the y value corresponding to that 0x is correct. And how are you going to do that? You go back to the worded problem. Okay, so the worded problem will actually guide you for this point. If your x is 0, then what would be your y? Okay, as long as you have understood the worded problem, it would not be very difficult for you for this one, if you're going to use the shortcut. But again, if you cannot do that, then you have no choice. You have to do the long methods, either substitution or elimination. So that concludes our lessons for today. So thank you very much for listening. Have a great day. Okay, so to tell you honestly, this is my first video lecture, or you could say it lecture video, and I am planning to do this from time to time, as long as this is needed. Okay, so see you again for my next video, and have a great day. Okay, see you next meeting. Thank you very much again.